Hello everyone. Before diving into today's topic, we want to take a moment to thank you for your support. Every like, comment, and subscription truly makes a difference and helps this channel grow. If you enjoy our content and don't want to miss our upcoming videos, subscribe to the channel and turn on the notification bell to receive all updates. Today, we will explore one of the most astonishing discoveries made by the James Webb Space Telescope, GLASS-z13, a primordial galaxy that has challenged our understanding of the universe. This extraordinary discovery could rewrite the history of galaxy formation, challenging cosmological models that have been used for decades. To grasp the significance of GLASS-z13, we must go back in time to the origins of the universe. After the Big Bang, which occurred about 13.8 billion years ago, the universe was a soup of subatomic particles, continuously expanding and cooling. Around 380,000 years later, electrons and protons combined to form hydrogen and helium atoms, marking the beginning of what is known as the Dark Ages, a period when no visible light existed because the first stars had not yet formed. Then, about 100 to 200 million years after the Big Bang, the first stars began to ignite, illuminating the universe with their intense ultraviolet radiation. This event marked the beginning of the so-called epoch of reionization, during which light began to transform the cosmos by ionizing the diffuse gas in space. Until recently, scientists believed that the formation of the first galaxies was a slow and gradual process, requiring hundreds of millions of years to develop into complex structures. However, images of GLASS-z13, captured by James Webb, tell a different story. This galaxy existed just 300 million years after the Big Bang, during a time when the universe was still young and deeply influenced by the events that would shape its future evolution. What makes GLASS-z13 an object of immense scientific interest is its apparent maturity. According to traditional models, the first galaxies were expected to be small, unstructured clusters of stars, lacking the complexity we see in more evolved galaxies today. However, GLASS-z13 appears to be a fully formed galaxy, with an estimated mass of around 1 billion times that of the Sun. This is a surprising fact. How could a galaxy grow so much in such a short time? One possible explanation is that GLASS-z13 formed stars at an incredibly accelerated rate, much faster than modern galaxies. If confirmed, this would imply that the early universe was more favorable for the birth of massive galaxies than previously thought. Some scientists hypothesize that conditions in the universe during its first million years were significantly different, with a higher density of matter and intense star formation activity. Another fascinating aspect of GLASS-z13 concerns its chemical composition. The first galaxies were primarily composed of hydrogen and helium, the lightest and most abundant elements after the Big Bang. Heavier elements like carbon, oxygen, and iron only formed later, thanks to the first supernovae that expelled material produced inside dying stars into space. However, analyses of GLASS-z13's light suggest the presence of heavier elements than expected. This could mean that the first stars in this galaxy formed, lived, and died much faster than previously thought, enriching the galaxy with new elements in record time. If so, we might be facing a new paradigm regarding how quickly the fundamental chemical elements for planetary formation, and potentially for life, spread in the early universe. But the surprises don't stop there. One of the most intriguing theories suggests that GLASS-z13 may contain a primordial black hole. If this hypothesis were confirmed, it would mean that black holes formed much earlier than we thought and could have played a crucial role in the growth of the first galaxies. Another key factor could be dark matter, a mysterious substance that makes up about 85% of the universe's mass but neither emits nor absorbs light, making it invisible to traditional instruments. While we cannot observe it directly, the gravitational effects of dark matter on galaxies are well documented. If GLASS-z13 grew so rapidly, it might suggest that dark matter was distributed differently than it is today, creating the perfect conditions for the birth of the first galaxies. Another hypothesis relates to the density of the early universe. Right after the Big Bang, the universe was smaller and denser, which could have facilitated galaxy mergers and rapid growth. Perhaps GLASS-z13 is the result of early galactic mergers, a phenomenon that might have been far more common in the first cosmic epochs. If these primordial galaxies are so large and structured, how many more could be out there? The James Webb Telescope has only just begun its mission, and many scientists believe that we will soon discover even older galaxies capable of rewriting our understanding of the universe. Each new discovery could bring even more astonishing revelations, helping us reconstruct the history of the cosmos with unprecedented detail. This discovery also has implications for the search for extraterrestrial life. If galaxies formed earlier than expected, the same might be true for planets. And if planets have existed for longer than we assume, then life may have had more time to emerge and evolve. This could mean that the conditions for life existed in much earlier epochs than we imagined, increasing the chances of finding traces of life elsewhere in the universe. The discovery of GLASS-z13 is not just a scientific curiosity, but a true window into an era of the universe we had never seen before. It forces us to rethink everything we thought we knew about cosmic origins and opens up new questions about the dynamics that shape the cosmos as we know it today. The journey to uncover the past of the universe has only just begun. Who knows what other surprises the James Webb Telescope will reveal in the coming years? One thing is certain. With each new image and each new analysis, we come closer and closer to understanding the great mystery of our existence in the universe. Thank you for watching, and see you in the next video.